Okay, question 6. A curve has an equation which satisfies d2y by dx squared equals 3x to the minus a half for all positive values of x. The point P, 4, 1, lies in the curve, and the gradient of the curve is 5. Find the equation of the curve. So I'm going to highlight all the key bits. So I've got the second derivative is 3x to the minus a half. I've got that the point P, 4, 1 lies in the curve, and the gradient at P is 5. And it wants the equation of the curve. Okay, so let's think about our key knowledge. So our key knowledge that we know is that by differentiating a curve, that gives us the gradient. If a point lies on the curve, that means x is equal to a, y is equal to b. And I've also got that if let's write to the side, to get from y to dy by dx, that means I've differentiated. And to get from dy by dx to d2y by dx squared means I've differentiated again. So to go backwards, the inverse of differentiation is integration. So that's our key knowledge. Let's now do some of the translation. So the point P, which is 4, 1, so that means that x is 4 when y is 1. And the gradient, so that's dy by dx, at P is 5, so that means dy by dx equals 5 when x is 4 and y is 1. Okay, so I've got my translation, I've got my key knowledge. So now let's do the algebra step and have a go at solving it. So I've got d2y by dx squared, so the first thing I can get is dy by dx, and I can do that by integrating d2y by dx squared with respect to x. So if I do that, I'm going to integrate 3x to the minus a half. Okay, and some other key knowledge is that to integrate something that looks like a constant times x to the power n, when n doesn't equal minus 1, then what I do is I add 1 to the power, so I get x to the power n plus 1, and then I times by the reciprocal. So I do a times, I don't think I left myself enough space to write that. Let me just write that a bit to the right. So I do a times 1 over n plus 1. Times by the reciprocal is the same thing as dividing by that number. And I also get a plus, see, I get a constant. When I integrate, I always introduce these constants. Okay, so let's have a go at doing that. So if I integrate, I'm going to have x to the power of a half, because I add 1 to minus half to get positive a half. The reciprocal of a half is 2 over 1, which is 2. So the front's going to be 3 times 2. And I'm going to have a constant. So if I just tidy that up, I get dy by dx equals 6x to the half plus c. Okay, if I zoom out so you can see the question again. However, the question tells me from my translation step, dy by dx equals 5 and x equals 4 at the same time. So I can use that information to hopefully try and find out what c is. So I know that dy by dx is 5 equals 6 times 4 to the half plus c. Well, if we work out what 6 times 4 to the half is, power of half means square root. Square root of 4 is 2. Times by 6 is 12. So I get 5 equals 12 plus c, which I can solve very quickly to get c is minus 7. So therefore, I've now got dy by dx is 6x to the half plus minus 7, which is just negative 7. Okay, I'm trying to get to y, so the equation of my curve is y equals. That's how it wants me to write my answer. Equation of a curve means y equals. So that means I need to integrate again. So y equals the integral of dy by dx with respect to x. So therefore y equals the integral of 6x to the half minus 7 with respect to x. And I can use my key knowledge. So I add 1 to the power, gives me 3 over 2. So times by the reciprocal, so 6 times 2 over 3. Okay, integrate 7. Well, 7, there's no x's there, so it's x to the power 0. So add 1 gives me x to the power 1. And then times by the reciprocal, so just times by 1. Plus a constant. I shouldn't use the letter c because I've already used it. So I'm just going to use k because that's like a c as well. The c could be any letter. We just use c to stand for the word constant. So if I simplify that, we get y equals, well, 6 times 2/3 divided by 3 gives me 2, times 2 gives me 4. So 4x to the power 3 over 2. Take away 7x plus my constant. But if I look back up my key knowledge from the question, I know that x equals 4 and y equals 1 at the same time. So if I use that information, x equals 4 and y equals 1, I get 1 equals 4 times 4 to the 3 halves. Take away 7 times 4 plus my constant k. So if I work that out, let's just type in my calculator for speed. I get 1 equals, the whole expression turns into 4 plus my k. So therefore, my k is going to be minus 3. Now I need to finish it off. I need to sub back in what k was. So my final answer is y equals 4x to the 3 halves minus 7x plus k, so plus minus 3, so just minus 3. And that's the equation of my curve. Remember, equation means I need an equal sign in there. Okay, I'm going to go back and go through the marks. So you get your first mark for trying to integrate once. So just like differentiation, an attempt to integrate could be adding 1 to the power, or is adding 1 to the power, sorry. So if you got power of a half, that means you get a mark. Then you get a mark for getting 6x to the half, so getting the number right, and you're allowed to forget the c at this point. They don't penalise you at this point for forgetting that. You get 1 mark for subbing in your numbers, so getting this equation here. Now, even if you didn't get the number 6, for example, say you did a mistake and you divided by 2, so you got 3 over 2 instead of 6, you still get this mark here. This mark's not for getting the right answer, it's for subbing in x's, dy by dx is 5, x is 4. However, you do get 1 mark for your answer, minus 7 for C. It's not a follow-through mark. So there's 4 marks so far. Number 5 comes from attempting to integrate again. So the same rules. So integrating your previous one. So making sure you've added 1 to the power. And then number 6 comes from subbing in your numbers. So subbing in x is 4, y is 1. And your last mark comes from getting the right answer for your curve.